How are you doing today? We are in chapter 4 of the Water and Wastewater Laboratory Techniques book. And we are talking about volumetric devices and the use and their measurements. When we talk about volumetric measuring tools, we're talking, the Erlenmeyer flask and beakers are the pots and pans of laboratory glassware, but they are not volumetric measuring tools. They're just approximate measuring. They have the scales on the side, but they're just for approximate measurements. They're not used for scientific measurement. And so, really, when we get in there, we are talking on page 74. There are five volumetric measuring devices recognized as suitable for accurate and precise analytical work. And those can be burettes, volumetric flask, uh, volumetric transfer pipettes, measuring Moore pipettes, and graduated cylinders. We want to use precise measurements when we are creating, our standards or we are reporting stuff to the EPA. And it talks about this in this book. Class A glassware, um, they offer it in two types. So the first type is Class A line that meets the ASTM standards, and then the second comes with documentation and traceability to the NIST standards. So your Class A glassware is your most precise glassware. When it has that Class A standard, you can feel safe in using that, and the degree of tolerances are not that big of a deal. On page 74 is a Class A volumetric flask. And right under the meniscus there is a line. And so what you would do is you would pipette your standard in there. You would fill up half of the jug or three-quarters of the jug or volumetric flask with DI water. You would pipette your concentration, let's say, of ammonia standard in there. And then uh, you would invert mix, and then you would add more water up into your meniscus is right level with the line, and then you would invert that several times to get a homogeneous mixture there in your volumetric flask. Um, this chapter is going to be um, kind of hard until you really get your hands on some lab equipment, and you can look up, I would recommend looking up burettes and pipettes and beakers and flask and some of these things. Really look up some images on the internet. They have some good images. But a lot of times when we're talking about flask, we need to remember that um, they'll have a definition, and that will be either to deliver or to contain. And why that is important is some are calibrated, especially in the pipettes. That a little is still left in the pipette. It's pre-calculated in the distribution when you distribute the sample out of that, and you never want to blow out that predetermined liquid that's in there. So, volumetric flasks, they are calibrated to contain. This means that when a flask is filled with the liquid to the mark, it contains a specified amount of liquid, such as 100 mil. And once again, it goes through to prepare a solution in a volumetric flask. A known amount of solute is placed in the flask. Some solvent is added. The flask is agitated until the solution is dissolved in the solvent. After the solvent returns to room temperature, some dissolutions generate heat when others reduce the temperature. More solvent is added until the flask holds about 1 to 3% less than the final. The solution is mixed, then allowed to settle, and the volume is finally adjusted to the mark by careful addition of more solvent until the bottom edge of the meniscus sits just on top of the calibration mark. Final mixing of the contents of the flask is performed by stopping the flask, inverting it, and then shaking it. This is repeated 2 or 3 times. So that's how we're preparing standards in the laboratory. When we talk about pipettes, we're talking about the Moore pipette and the serological. So the Moore pipettes is graduated from a zero mark near the top of the pipette to the baseline near the tip of the pipette. Thus, the Moore pipette is to deliver device. Measuring pipettes are calibrated with either a Class A or Class B tolerances. A serological is different. It is graduated from the zero mark near the top of the pipette to the tip of the pipette. The serologicals are labeled with the total volume and the volume divisions similar to Moore pipettes. And I believe serological, um, they are, let me, um, they are labeled. Uh, so A would be your volumetric pipette. You can see where there's a bubble where it would hold on page 79, hold some. There's not a very good picture, but B would be your Moore pipette, and then C a serological pipette. You really can't see in these pictures the difference between those. But you need to go on the internet and really look at the serological and the Moore pipette and see the difference between the markings. You know, some of them are to deliver, especially in the Moore, and then serological. Volumetric transfer pipettes have a bubble in the shaft and only a single volume. And this says that some volumetric pipettes are calibrated to contain, but they are rarely encountered. The most of them are to deliver. So really knowing whether or not you should blow the pipette out or not. That's crucial when we're talking about the different types. And then the final type of pipette is the bacteriological pipette, which is designed for use in the uh, dairy industry. When we talk about burettes are indispensable tools for titrations. A burette is measured with a measuring pipette with a valve at the bottom, allowing the disperse of a tightly controlled volume of reagent with known accuracy. So it kind of looks like a pipette, and then you have a ball cock on the end of it, and you drip the either the reagent in or some other chemical in to get your titration. And we use that in like alkalinity testing and hardness testing. You can see a picture of a micro burette on page 82. And so once again, you can kind of really finely uh, slow down the volume that you're delivering to your sample with a tighter degree of certainty with a ball cock like that. 81, if you're doing something like 100 mils or 200 mils, that's a good graduated cylinder on page 81. Um, it's important for proper use of volumetric glassware. You know, the first consideration in use is temperature. All glass expands and contracts with the rise and fall of temperature. Different types of glass have different rates of expansion. So knowing our temperature in our lab, knowing how um, how our glassware is going to work. I want to highlight this. Reading graduated cylinders and measuring pipettes and burettes frequently require estimating the position of the meniscus between the calibration marks. If the container is to contain device, the entire contents are the correct volume. When transferring the contents to another container, simply pour the solution from the to contain device to the new container maintains the concentration of the solution. However, all the liquid will not be transferred. Um, to deliver device, a flow time is specified. The tip internal diameter is designed so that the desired flow time is established as the pipette empties by gravity. Pushing the liquid out with a pipette ball defeats the design. So you can kind of see, where they're putting their hand over the pipette. One thing we want to do is never pipette by mouth. They make bulbs that can suck up your standard and empty. So we always want to use a bulb or automatic pipetter. Knowing your correct position, you can see in figure 85 off to the left, that is reading the meniscus right. You can see at the bottom of the meniscus is right on the line. There, obviously, they've filled it too far, or perhaps they filled it when the temperature was not at the correct amount, and then they have an inadequate measurement there. Another picture of a position of a meniscus in a graduated cylinder. So you can see that that once again is too high. You're right at like almost 53 there. So you read to the bottom line of the meniscus. Um, there's a pipette bulb. The bulb is placed over the wide end of the pipette and the bulb is squeezed. um, when you first pipette, I recommend just doing regular water because everybody always squeezes water too far up and gets into the bulb, and it's easier to clean that way. Um, but many of bulbs have been ruined by sucking up acid into the bulb. Really, pipetting is a skill set, and having someone show you how to pipette and knowing from what level of the container to pipette, and just watching a skilled pipetter is important. And one thing we always want to make sure that we're not doing is pipetting up, using some, and then putting that standard back in there, because we're always going to get cross contamination when we do that. Volumetric flasks are not storage containers. Once we use them to get our predetermined level, we want to use a glass storage container instead of using those. Those are expensive, and just in using those, we may get damaging. Calibration of non-standard measuring tools. You can calibrate this coffee jug. Um, I've never really done this. I've done this for the test and to show people. But the first thing you do is let everything uh, get to room temperature. Place the thermometer in the container of the reagent water. Dispense a volume of water from the device to be calibrated onto an analytical scale. Record the weight of the water in grams. Repeat this 2 or 3 times. Calculate the average. Record the temperature. Look up the density of water in the table and divide the average by the dispensed water by the density. The result is the actual volume dispensed in milliliters with a higher tolerance, tighter than Class A standards. Then you can tag the device and keep records of the calibration in the notebook. So if you really wanted um, to calibrate a non-standard measuring thing, you can. All one needs is an analytical balance, a reagent water, and a standard thermometer, and a calibration book, and a table of water densities. You can mark that glassware. One fashion is to put a permanent mark on the glass using a laboratory marker to mark the correct. Then you put a layer of melted parabellum wax is brushed over and allowed to cool. Then using a razor, remove a thin groove of wax over the marked down to the glass and fill the groove in with the wax with the concentrated hydrofluoric acid and wait an hour or so. The acid will etch the permanent mark in the glass at the desired point. Another way is you can use a sandblaster that you can get um, to market. I'm going to be honest with you. I have um, never really went through the steps of doing that to mark non-standard glassware. I've always just used what has been provided from our contract supplier, and just use that. But maybe you are working at a lab where it requires you to do that. Um, and you need to mark more glassware. Needless to say, ASTM Class A volumetric measuring pipettes, volumetric flasks, and graduated cylinders and burettes are preferred measuring tools for solutions in the laboratory. I know this was a really fast down and dirty on volumetric glassware, but really spend some time, in your wastewater books or look up the different laboratory. They make great things on YouTube that you can look and become familiar with your measuring devices.